here I've divided some of the things that we're going to speak today about into somewhat more for educators and somewhat more for students. However, it's really important to think about the process of education as a collaboration between educator and student, right? So even though I've sort of quasi-arbitrarily drawn some lines between what's a little more applicable to educators and what's a little more applicable to students, I do hope that each cohort finds a lot of useful information in the section which is slightly more tailored for the other. So we're going to talk about a few things today. So first of all, let's talk about what sorts of AI tools are out there. When we're talking about AI tools, there's a few different types of tools that are important to know about because different tools have different strengths and weaknesses. As we're reaching for the correct tool in our tool belt, we want to keep in mind which ones are particularly easy to use for which tasks. This will help us decide what the right tool for the job is, just as though you were doing anything. AI tools are no different than that. So then, as I said, there's some workflows which are a little bit more applicable to educators, a little bit more applicable to students, although there is a lot of crossover since educators and students collaborate in the learning process. And then also, hopefully, you'll get some important tips today. As you see, this right now, by the way, is a chat-enabled notebook. So as we see how some of the features of this work, you'll get a brief primer into how some of this works as well, in case you're wanting to use it for your own projects. All right, let's jump right into it. So what kinds of tools are out there? Let's start with generative AI. So if we ask a persona here, so this is Bernardo, who is a really fun persona. I think no talk on generative AI should be complete without using Bernardo in a chat notebook. So the gist of generative AI is that it creates things. And typically it's going to create things based off of textual prompts. So let's say that I wanted to put in a textual prompt into my notebook here. Now notice a couple things. I'm putting in here this gray cell, which is called a chat delimiter. And in a chat-enabled notebook, the way that you do that is just by using a tilde. So if I put in a tilde here into just starting typing, I get one of these delimiters. Now, let me now say into a chat cell, which I get by using the apostrophe key by default. So now let's talk to a different persona. Let's talk to, let's say, the science enthusiast persona that is built into one of these chat notebooks. And let's say to the science enthusiast, what is generative, oops, can't spell today, AI exactly. And so we'll see the sort of different behaviors that we can get as you give these generative models different prompting. So these personas effectively boil down to some pre-prompting that's done in terms of a longer block of text that tells this text generation thing. So this right now we're using GPT 3.5 in this particular case. You can also, if you want to, go over and talk to other models like GPT-4, adjust some other settings. We'll get into a little bit more detail about that as we go. But you can see that these personas modify the behavior. So Bernardo has been told, you're a cool bird, right? Use things like emojis because those are the kinds of things that cool birds do. But the science enthusiast has been given some prompting that tells it that it's an explainer of science. So you can see that this difference in behavior, right? We had, other than talking to a different persona, we asked the same question, but by prompting it in these different directions, by invoking these personas, we get a more in-depth explanation. It brings up things like neural networks. What else does this one do? One of the exciting things about giving presentations related to generative AI is it's always a little bit random what comes out. We'll see some more manifestations of that as we go. So we can also invoke these sort of modifiers. So this explain like I'm 5 modifier, if we use, let's say, the Wolfie persona here, this tells the model, okay, I want to explain this concept, but I want to do it in such a way that, you know, a bright 5-year-old would not have too many more questions. And so I liked this particular iteration of it because one good way of explaining how is something like ChatGPT different than just a search. So this was, I think it did a pretty good job of capturing the essence of it in a way that is not too difficult to grasp in terms of everyday concepts. So it's like when you learn how to draw a flower by looking at lots of different pictures, and then you can draw your own unique flower without copying anyone else. So the things that we're getting back here when we're talking to a generative AI, like any of these OpenAI models that generate text, it's not quite as simple as them going and looking things up, right? They have this training data that gave them a whole bunch of information about the types of things that people are likely to say in text communication. And from this training data, and then some other processes involving reinforcement learning to try to get them to be a little bit more on the rails and follow instructions in terms of their prompting better, we're able to get a system which this conversation never exactly happened in its training data, but based off of all of the things in its training data, which is similar enough, it's able to generate some text which does a reasonable job of answering my question here, asking a particular persona, in this case Wolfie, who is a helpful code assistant in the Wolfram language, and then explaining at a particular grade level. So as I mentioned, today's generative AI does involve random processes. So let's actually ask Bernardo the exact same question again, and we'll see that Bernardo is not going to behave in exactly the same way. So the previous time I asked Bernardo this question, he decided to use a sunglasses emoji, for example. That's a really obvious thing you can see. But if you actually read this in detail, it's the same gist of what he has to say, but there's a slight variation in what actually happened. Now, when you're talking about text generation versus image generation versus other things that you might want to use generative AI for, it's important to note that there's always some sort of process that involves random sampling. So in the training of one of these large language models, like the ones that are hooked up to these chat-enabled notebooks, what their training tells them to do is, given a bunch of words, what is the next most likely word to come? Now, that's a slight simplification because really they're not looking at words. They're looking at these things called tokens, which are pieces of words. But that's a detail you don't necessarily need to worry about in terms of understanding why they have some randomness. So if you think of them as just predicting the next word, in any given sentence, you can imagine that there's some probabilities for what words are likely. Now, as a part of their training data, they've got some sense of what the next most likely words are. And then you need some process for picking which word to actually use. If you just pick the most likely word every time, it turns out that's not as quite a useful thing to do as if you have some sampling process where you sample words which are still likely, but not always the most likely word to come next. And then this allows you to get some nice variation because maybe the first explanation might have been better or worse, as opposed to a different variation where the random sampling gets us a slight twist on what the original answer was. And the other thing is that no one writes the average essay. If you take all the essays that people write, you can come up with an average, but no one person is going to write that exact average essay. So this random sampling process is really key to the way that all generative AI of today works. So that's why if you ask them the same question, let's do it a third time even, we'll get slightly different answers every time. And so in these chat-enabled notebooks, we can see here we got some different emojis, right? So going back and forth, you can see different responses that you get running these different times. Now, not to get too much into the details about this, but if you'll notice here, I put this delimiter cell right here. And again, I can do that using a tilde. So what this does is it puts a block here so that when I'm asking Bernardo a question, Bernardo isn't reading what's coming above in the notebook. We'll see some examples where you actually would want your model to be able to read what happened previously in order to have some really exciting and new workflows. But because sending information off to these large language models does cost real electricity and therefore real money, you want to be very mindful about what you're sending. So, you know, if you just want to ask a question that's a question different from the previous things you've been doing, put in one of these chat delimiter cells so that you're not sending extra information. That will both, you know, prevent spending unnecessary electricity on it, but also the context, as you'll see, is everything for the outputs to these large language models. And so you want to give it just the context you want, no more, no less. All right, so moving on. Generative AI we'll talk a whole lot more about, and you'll see some workflows for as we get further into the presentation. But what are the other kinds of AI tools that are out there? So many of you will be familiar with Wolfram Alpha. So Wolfram Alpha works under a very different operating principle than something like ChatGPT. So the goal of Wolfram Alpha is to reliably translate natural language into the same computation each time. So in other words, if I just want to know what's the population of Chicago divided by the population of Illinois, unless this data changes or unless my query changes, so let me run this exact one again. So we'll load that up, and here we get the same graph, the same percentage, because none of this information changed just because I asked this question again. So note that Wolfram Alpha is not one of the examples of a system that has randomness built into the answers that you're getting. In order for the output here to change, either the data would have to change that this is hooked up to, or someone would have to go and change the source code, maybe to add in some new features or something, so that then there's new things that can be translated. So it's a really important conceptual difference. Generative AI takes prompting in text and then generates more text based off of a large corpus of training data, and there's some random variation in what you're going to get every time. Something like Wolfram Alpha, this is built using a symbolic programming language. This is going to give you the same output every time. So some other sorts of things, let's say that you want the GDP of every country. We don't want any randomness here. We just want to know the data, right? I don't want this map colored in with random colors. I want to be able to just go and have a color that corresponds to the actual numbers. If we want phase diagrams of water, if I run this a second time, we'll get back the same phase diagram because nothing has changed about water in between me asking here, and I don't want any random processes to change the answer here. If we want to do things like chemical reactions, right? This reaction, the actual molecular dynamics involve a lot of random processes, but if I just want information about it, the information shouldn't depend on random process here. And so that's the mission in life of Wolfram Alpha, is to translate natural language into the same computation every time. You know, mathematical things shouldn't depend on that. Now, the thing is, no one's ever accused Wolfram Alpha of being creative, right? So Alpha doesn't tell me an essay about this. It just gives me what I asked for. But then it might do some other things like give me a plot or something. That's a bit creative, but it's not going to generate the sorts of things that are variations on this idea. It's going to give me what I asked for plus some other things. So because it has a different mission in life, its job is to be reliable and just provide the computation that corresponds to what you wanted. That means that it's effectively a different tool than some of these generative systems. So that's an important thing to understand when you're reaching for different tools in your tool belt. Depending on what you want to do, let's say that you're calculating Riemann sums and you want some nice visualizations. You want to change the interval size. Let's make it, I don't know, 0.1 here and compute that. Again, these are the sorts of things that if this is what you want to do, great, this is the right tool for the job. If this particular thing of taking natural language and turning it into a specific computation isn't what you want to do, then generative tools like you can access in these chat-enabled notebooks are a great way to do it. So we should also mention that there are traditional machine learning techniques that were sort of the predecessors of generative AI. So this generative AI is very exciting new technology that enables some really cool things. But don't forget that there's other things like computer vision, classifiers, all sorts of unsupervised learning techniques like detecting anomalies in data, natural language processing that goes into things like both Wolfram Alpha and a lot of the techniques that eventually led to ChatGPT. So one of these machine learning methods, which has been around for longer, might just be what you want for a particular project. You know, let's say that you have a student that's interested in learning about data science. And so there's this example data set of survivors of the Titanic and some other data about them. And then you can, let's say, train a classifier in just a single line of code. And then you can use that in order to get a nice plot that shows an estimate based off of some information about the passenger. How likely were they to survive this disaster? So you can see that in all cases, the younger passengers were more likely to survive than the older passengers in the case of this disaster. So again, there's nothing generative AI about this. There's nothing particularly Wolfram Alpha about this, but it's just another machine learning technique, which might be what you want to do for your particular project. So keep in mind the areas of AI tools that you might want to reach for when you're thinking about how am I going to apply AI to education. Okay, so let's now get into the really fun part, which is how we can combine tools for best results and get some new workflows. So in the materials that you've been provided, there are these links to the Wolfram plugin for ChatGPT announcement, the chat-enabled notebooks announcement. So do make sure at some point, if you want to see more cool examples than what I'm going to show you today of some of these things, Also, there are Wolfram U webinars about the Wolfram plugin, study groups, all these good things. So do check out these for more details if you want to go more in depth about any of those. Now, let's also briefly just remind you about what the plugin looks like in case you haven't seen that before. So what I'm going to do here is switch the screen that I'm sharing. So you should see the ChatGPT interface here. So here you can choose plugins if you want to use a plugin. And so what does a plugin allow you to do? So let's use Wolfram, to write a brief essay on the economy of Singapore. So if we ask for this, and then we wait for the OpenAI interface to do its thing. So I'll show you what that means, the fact that it's using Wolfram here in a minute. So it's going to go start typing. Don't worry about the specific things here. This is probably a little bit tiny on your screen, but I'll point out some key features as it's going. So in this essay, it's including some numbers. Now, if you just use a generative AI that has seen all this training data and it's coming up with numbers, are you going to trust that number? Well, maybe, maybe not. So let's go ahead and stop it generating here in just a second. Okay, so it was about to go into value added by sector. So again, if a generative AI is just coming up with numbers, the question is, where are these numbers coming from? Is it reliably going to somewhere in a data set that it has access to? Well, in the case of this plugin, what this is doing is it's asking for an economy of Singapore overview to Wolfram Alpha. And then Wolfram Alpha is going and saying, yes, there's all this information here that has been curated according to these estimates in these given years. Humans have made sure that this information is coming from reliable sources and is hooked up properly to the database. And then we can feed this information into a generative AI so that we're able to see specific information that the generative AI ChatGPT can use in order to do some task, in this case, write an essay about the economy of Singapore. So that's one example, and I believe the first example that was released of combining these different approaches in order to get some exciting results. So now I will go back to sharing this chat-enabled notebook, which is really the main focus of what I'm going to be talking about today. But it is worth definitely keeping in mind the fact that these plugins are out there. They're quite exciting, and they can be potentially very useful for things you would want to do in education. So we're going to do another fun toy example here. So this is a really fun toy example. So text generation AI is actually not the only generative tool which is out there. So in fact, image generation came into maturity a bit before text generation like ChatGPT did. ChatGPT is now quite impressive, but there were image generation models that could do really fun things well before ChatGPT could. So let's say that here we've got a photorealistic picture of a calico cat. Now, the internet is full of cat pictures. No one person's cat is represented here. This is a lot like that explanation that we got from the Wolfie persona before. This model has seen in training data lots and lots and lots of pictures of people's calico cats. And it's decided, based off of all those training examples, the types of things that it should look like to have a picture of a cat. Then you can use a traditional machine learning model. So here, this is one that instead of taking text and turning it into a picture, it looks at a picture and it says, okay, here's the image, here's a concept that I find represented in it with this probability. So it's sort of a fun little toy example here. This computer vision model with 91% something probability agrees that, in fact, yes, this image here is a picture of a cat. And then we can even highlight where these sort of vision models in the images are going to find these things. So again, just to emphasize that these generation models give us a little bit different outcome every time. Let's just get one picture of a calico cat in the middle distance, and we'll see what that looks like. Going and connecting, getting our picture, coming back. You see image generation sometimes does take a little bit. And here we have a picture of a cat. And so then if we want to take this particular picture of a cat and we want to, let's do the image contents of this particular image of a cat. Whoops, I want this one. put this here, and we'll see, yep. So in this case, this is another interesting thing that will happen sometimes. Notice that I only asked for a picture of a calico cat, but in fact, yes, there is a picture of some kind of furniture that here our vision model says this is probably a chair with 65% probability. Could be some other piece of furniture, but probably a chair. So when you're asking these generative models for things, this is actually a really nice, I wasn't expecting this to happen because usually it just does a pretty good job of giving a calico with a generic outdoor distance. But here we have this other object. And so you can do these post-processing techniques where you go and you say, okay, given what the particular model has generated, am I actually finding what I asked for in terms of the output of the image that was made by this generative model. So here's a really fun example where, yes, I got a cat, but I got this other thing that maybe I wanted, maybe I didn't. So that's a fun toy example that actually proved to be surprisingly reflective of the sorts of things that you worry about when you're dealing with generative AI. All right, so one of the exciting things that you can do is you can help design classroom activities with code written by one of these generative models. So aside from just generating text, if you can write text, well, then you can write text that corresponds to computer code. So if you want to follow along in more detail sometime, reading in more detail the sorts of things that go into co-designing a classroom experiment with one of these generative models, I do encourage you to take a look at that at your leisure sometime. In the meantime, what I'm going to do is I'm going to talk you through just the key points so that then we can distill down what were the key human inputs in this interaction with the generative model. So one might start by speaking with the design thinker persona, which is prompted to think according to the design thinking curriculum that you might find at some place like MIT. So we might say, help us design an experiment for high school students about some particular thing like conservation of momentum. And so we get a nice step-by-step of how you would use design thinking in order to brainstorm such things. And then when we get to the iterate step and the testing step, so this is reflective of a conversation that I had with actual high school students before generative models like this had really come into the main. So this is a sort of post hoc how one might do this particular classroom experiment after these models exist. So after speaking with some high school students, they want to use a particular experimental setup. They want to measure the height of a ball after bouncing, help them design the experiment, make sure that the list of procedures is clear, concise, and appropriate for grade level. So we get a rather nice description. So then we can say, let's take a look at the previous experimental procedures to the design thinker and suggest some alterations that could be made in order to introduce dependent and independent variables. For example, this particular thing that we actually did use in the classroom. So we get a nice revision. And then sure enough, this description of the experiment is quite similar to what before these generative AI tools existed, what I typed up by hand when working with students before joining Wolfram Research. So had I had tools like this back then, the amount of typing that I would do compared to what the models would be able to create for me is much different ratio nowadays. So I was pointing through some of these things, I think, without the screen being properly here. So at any rate, this is linked in the notebook. Do please take a look at this at your leisure, because again, the important part that I want to emphasize here is that you take a look at the key human inputs to drafting an experiment design and getting some code that your students can use. So let's return to the presentation notebook. Make sure my screen switching works properly this time. Apologies. And so now we should see that we get our initial idea where we help design something. We have instructions to refine the outputs. So in this particular case, after I discuss things with students, after we introduce our variables, we want to help students analyze and present the data. So these refinements come from the human user, from the instructor. Now, we introduce key concepts here. So the idea to use a linear model, inelastic bounces, the vocabulary term coefficient of restitution, this all came from the human in this case. You could have a conversation with the language model, and these kind of things will come out of it eventually, depending on the context of your conversation. But if the human user knows that this is what you're interested in and just cuts to the chase and introduces this context will help the model understand much better what it should be doing. So if we introduce corrections, notice that because there's random processes when you're dealing with a large language model, not every single thing it says is going to be correct on the first time it generates it. So if you introduce these corrections or do some kind of post-processing if you want to get really fancy, and then use this to correct what the model is saying, then you can take this somewhat random behavior and try to refine it until we get something which is better and ready to put in front of students. And also these relevant extensions of helping a student interpret their model. And then in this particular case, the generative model actually came up with its own idea that, wait, that's not how a ball bounces. We in fact want to use an alternate model than the one I first suggested. But generally speaking, the human user will be the first one to notice something like that and suggest it. So co-designing, this could be co-designing experiments, it could be co-designing assessments, co-designing all sorts of things, especially ones that involve code, potentially code that you are not familiar with yourself, but that the model can help coach you through how it works. So this is one new workflow that, again, educators will find very helpful. Students potentially can as well. We can also look at new ways to assess. So I say new here because having assessment which is based off of strategy and problem solving instead of the fine details about calculating this or that particular thing is definitely not new assessment advice. So because the ways and the tools that we have to assess sometimes have various constraints on them, there's still a lot of assessment which doesn't always focus on strategy and problem solving instead of the fine details. So we have this new kind of assessment. So there's a paper that introduces this idea called a prompt problem, the original source linked here. But I thought this was a really cool idea in the literature. The idea behind a prompt problem is basically that you take some setup. So here we have a pendulum released from rest at a particular angle. We have some particular parameters, and then two differential equations that are used to model this system. Now, this is all of the information that a student might be given on a prompt problem, plus whatever classroom lessons they've had previous to this. So maybe you've got a flipped classroom, you've introduced some of these ideas before. Now, I remember when I was first learning how to solve equations like this and study a pendula, that I learned how to write these equations down well before I ever learned how to solve them. So now you have a new tool where students can focus on the strategy. So as the human input, you might say, I want to solve each of these equations. I want to use these particular functions to solve each one. Remember, model, please include the initial conditions that were given. Remember to rewrite everything so that you're using the information that was provided. I want to plot both solutions on the same plot. The legends should say, one, I've made an approximation, the other I haven't. And then I want to plot the difference between those two solutions in an additional plot. Please write a single block of code that will do these things for me. So the student, from a sort of a top-down thing, has been presented with some situation. They've said, given the situation, this is what I want to do strategically, right? If I was doing this by hand, I would then have to worry about all the details that go into making sure I do these things correctly. But if I want to first really focus on the conceptual problem solving and the strategy, learning how I can frame a problem, I could now just type in this, and then the model gives us a block of code, explains a little bit about what it does, and if we run these, sure enough, it looks pretty good. Now, let's see how good my prompt is upon running it again. As you'll recall, we get somewhat random outputs every time. So this particular prompt, I'm guessing this is reasonable, but I could have probably done better. And so every time I run this, it might not work every single time. In fact, there might be some times where the model writes some code that doesn't quite work. So let's see how it does a second time. Okay, not bad. It's still writing. Okay, that looks pretty reasonable. Let me check a couple things. Okay, so I think this is probably not going to work for subtle reasons, but let's see. So let's put that there, and let's see if it works this second time that it tried. Yeah, so as you can see, it did make a small mistake that has to do with giving an argument to this thing. Again, you can either have a conversation with the model, you could be a little bit more specific in your prompting as you see the sorts of things that it might occasionally make mistakes on, or if you happen to know parts of the language, maybe you weren't familiar with it enough to see every single thing you might have needed to do. But when you get output that looks like this, maybe as a human user with some background knowledge, you can say, oh, I see what you did there. So in effect, we didn't provide arguments to these functions. And so when we tried to plot these functions, we got something which didn't quite work. But if we go back and look at the first thing that this model did, it did work because it was more careful about that. It asked for slightly different things in terms of when it was writing down these functions and asking for things. So again, here it followed a very similar strategy. Some random variation made it not include quite the correct stuff. And so we got something which mostly was what we wanted to do, but it didn't quite get the plots right. So again, important to note that when you're working with generative models, there is a little bit of randomness. Worth mentioning, if you want to adjust something called the temperature of these models, the temperature affects exactly how much you are going down and looking at the less common but still somewhat likely things to choose. So you don't need to worry about the technical details of that. In general, the lower temperature is going to give you less variation in the outputs. A higher temperature gives you more variation in the outputs. But empirically, people seem to find that there is some middle ground for temperature that works pretty well, where if we are too predictable in what the generative models are predicting, then the output isn't quite as useful for humans to read and to use. If we go too high, it becomes nonsense. And so there's some sweet spot of temperature where we get pretty good behavior. There's some randomness, but not so much that it goes wild. Okay, so what were the human inputs that make this particular example work? So again, we have this initial idea. The student was given the physical situation and some models. They were given instructions to refine things, introduce key concepts, and go on. And in this case, if we ran it a second time as well, we would need to either in conversation with the model or just ourselves figure out, okay, where did I not put a bracket T bracket that made this not come out quite right? So the key point for educators and students here. So in these last two examples that we've seen, there was an initial question and idea. We can lean into this for student-driven exploration. We can refine details. We can introduce key concepts. We can critique the outputs of these generative models and offer corrections. And we can provide relevant extensions. So you've seen you can either go through a process where you're sort of co-designing solutions with a back and forth, or you'll see some more examples as we go later. And with that prompt problem that we saw before, the more background that you provide to one of these models, the more likely that they will give you exactly what you wanted on the first try. So what that means is that instead of worrying that large language models are a reason for students not to think about their work, you can use these key ingredients here as reasons for students to critically and creatively think. So again, if you lean into these features of generative models, rather than worrying about them, they can actually help a lot of your education workflows. So some more advice on assessment really quick. If we want to assess constructively so that the assessment is beneficial to the learning process, we need to provide, how are we evaluating what the student provides us? So that helps both in giving feedback, doing the evaluation, and for the student's learning. So is it right is not going to be a specific enough criterion except for some very particular formative assessments. So if you want to align your assessments to your learning goals of critically and creatively thinking, this is a much older unsolved alignment problem than the human AI alignment problem that you might have heard about in the news, right? So educators for decades and decades have had this alignment problem that our tools we use to assess are not always assessing what we really want to in terms of critical thinking and creative problem solving. So given this new technology, now there's all sorts of assessment items that large language models will make really obvious if they're not requiring very much human input, right? So project-based assessment that require design decisions and communication that go beyond a single one-time prompt to a large language model. These are the sorts of things that, because of the random variance you have in large language models, if the model has some small probability of successfully completing your project-based assessment based off of a simple prompt, and instead the student is using it for co-design, where the student is making design decisions and communicating ideas, well, all of a sudden, this is now an even more attractive way to assess than it might have been to you previously. Now, I want to make the point that, simple problems like calculate the integral of sine x or something, that's fine as formative assessment. By formative assessment, I mean the kinds of assessment that are testing, are we understanding little building blocks along the way to some larger conceptual understanding of what it is that we're up to. But the summative assessments, the kind of things that you do as large projects, these really should go beyond the sort of simple problems that one prompt to a language model is going to give you a good answer. So revising and peer assessment have always been powerful classroom tools. So in the literature, you can find some interesting examples of people that are treating large language models like an always available peer for generating content that then students can revise and assess how did my peer do. And in collaboration with this large language model peer, we can get some nice student critical thinking. The students can make decisions and they can provide their own input to something which is produced in conjunction with them and one of these large language models. And so that is the type of thing that's not so different from peer assessment that has been a popular thing for a while. Now, none of this advice about assessment is new, right? Our relevant tools that we have in order to do these kinds of assessments is more than it used to be now that we have chat-enabled notebooks, we have generative models. But educators have already been talking about these sorts of assessments for a very long time. And so we might ask a model, do you agree or disagree with these assertions about assessment in light of your knowledge of educational psychology and constructivist theories? And so last time I ran this, I got a nice marks, so to speak. So in summary, these assertions are largely consistent. So let's see if we do this again. Did it give me good marks due to random variance, or does it really think based off of the training data that it's had, is this good advice? And again, notice I've put a chat delimiter here, so I'm only showing it these bullet points when it's coming up. So here it's going to reassess what I had to say. Saying yes, right. Okay, so apparently somewhere in its training data, either it has or it thinks it has seen something about these things. So overall, these are consistent with these. Yes, so again, highlight the importance of aligning your assessment with your real learning goals, promoting the higher order thinking skills, and providing opportunities for active learning, collaboration, and reflection. So all of these things are things that are really helpful when students are dealing with large language models. So in my opinion, we should not be afraid of these as educators. We should really lean into these features of them because it already aligns pretty well with what we should be assessing anyway. Okay, now, we had a question previously about training data and how this factors in. So if we ask the raw model, what are some limitations on the data available to you? There is a cutoff date in terms of when the training data quit looking at things that were available to it, right? The training for this happened, at least in terms of its initial, large-scale batch of training. They only go up to a particular date. So if we ask the model, up to what year have you seen current news, it provides this particular date. Now, it is possible to give these models tools for various purposes. For example, the 2022 Winter Olympics were something which in the raw training data for one of these large language models, this particular model wouldn't have seen yet. But we can use, if you check out in the prompt repository, there's functions for, say, summarize URL content and then feed it the URL to the Winter Olympics. We get a nice summary of this article. So how can you do these sorts of things? Well, you can make a tool quite simply if you want to do something like read Wikipedia articles. So here we have a tool for reading Wikipedia articles. We can ask a question like, which country won the most medals in the 2022 Winter Olympics? Please use the tool that you have for accessing new data. Again, the context is everything. If you omit this, sometimes it will actually tell you, even with access to the tool, that, oh, I don't know because I don't have access to that new data. So again, the context that you give it in terms of the initial prompting is everything. So if you just add something as simple as please use the tool that you have, this can drastically affect the behavior and how often it will decide to use the tool compared to not. So let's now again, just to illustrate the sort of random variation that we can get, let's run this again. So we've given it this tool where it can search a Wikipedia article. we're taking only so much of the beginning of a Wikipedia article because we want to make sure that we don't run into any context limits with how much text we can feed to one of these. So you see here, we get a slightly different sentence, but it used the Wikipedia article that we gave it the opportunity to search in order to say, yep, Norway won the most medals in the 2022 Winter Olympics with these numbers. So it's being consistent according to that Wikipedia article. So the takeaway here is that giving large language models the tools to look things up for themselves, for example, a lot like the Wolfram Alpha plugin for ChatGPT does, gives them a lot more reliability because they can see some data presented to them and they can incorporate this into their baseline capabilities. Okay, so students, I hope, have already got a lot of good takeaways from that section that was more for educators. However, let's also get into some workflows that are good for students. So students can have opportunities for understanding that go beyond their time in the classroom, right? So a very common question that students always ask, and I think is a fair question, is how am I going to use this? So let's say a student is learning about linear programming. So we might say, I'm learning about linear programming problems in my business class. Why am I doing that? And we get a nice answer. We can even say, please invent specific values and write down a version of this problem in mathematical notation. It does so. And then we can say, please write some code that solves this problem. And so we can get a really nice, so here's a concept. Why does it matter? What's a specific application that shows me why that concept matters, where I've filled in the details, and then let's solve it. So that process is something that students are doing in the classroom, but let's say there's some area that you want more practice with, or you might not have in the class that you're taking currently, but you've heard about it and you find it interesting. People are finding that students really enjoy using these sorts of tools as sort of an always-on partner for having these sorts of conversations. Perhaps a student is shy to speak with an instructor immediately. Perhaps they want to explore something themselves before speaking with an instructor or a peer about it. So these models are ways that one can do that. It can also help correct mistakes and explain results. So let's say that you're wanting to make a plot of the population density of Europe, let's say. Well, if we do this, okay, this is a plot, but the colors are not quite what I expected here. So if you're not either familiar with the language or you're not familiar with this data set, it might not be obvious to you, wait a minute, why aren't these colors what I wanted probably? So again, here we have the importance of human context and background knowledge coming in. So if you can recognize that this was caused by an outlier in the data, you can say, oh, wait, I maybe don't know enough about this language to know how do I fix this immediately, but I could ask the model. So in this code above, how do I set this range so that I'm removing the outlier? And let's say I want to go to a particular upper value and minimum value. And so sure enough, the model is familiar enough with code to say, yes, if you want to do this in Wolfram language, there's this option plot range, quite easy, insert that, and then you get the plot that you're looking for. Now, if you know the language, this might have occurred to you immediately. But as a new student learning the language, you might not have known that this was even an option. You might not have known that options were even a thing. So if you're just taking a look at something and you've made it this far and you don't yet have what you want, well, now there's a nice code assistant available to you that can help if you're able to provide just a little bit of instruction. There are longer versions of this conversation that you can have. You can go in saying, help, this doesn't work. What do I do? And in a couple of back and forths, you'll be able to eventually get to this point. But the model might try some other things like changing the color scheme or what have you. Because if you're not specific, it might not understand exactly what the problem is that you were having and the problem that you wanted to fix. So if you can provide that extra context, I suspect there's an outlier country here that has some really high population density because it's got a small land area, let's say. If I exclude that outlier, that would probably fix this. If you can provide that as your input to the assistant right away, boom, can tell you how to fix this, even if you didn't know that this option was a thing. And then, of course, another thing that's quite good at, so you can use the large language model to help work through and understand existing examples. So let's say that you're looking through examples of code that people have. And okay, so this is some problem in mechanics. We have a beam that's hung from one end, and it's sagging a little bit because it doesn't have support at the other end. Well, in the grand scheme of things, this is not that much code, but it can be quite intimidating to a new student. So now, luckily, you can put this into a notebook and you can say, please explain this. I'm new, be concise. And you get a nice explanation of what it is this code is doing. And even more cool than that, so you can say, all right, using this example, I now understand that there's some function here which is relevant to fixing the sides of this particular model, right? So this sequence of equations is supposed to be modeling a beam that's supported on one end but not the other. What if I want to actually support it on both ends? What might happen? So if the student can at least point the model, okay, maybe look here, how do I fix it at both ends, right? So this is actually a quite simple fix if you go yourself and look at the comparison here, and the model does a good job of explaining, right? So all we needed to do was say that if it's at this end or the other end, then fix the beam. So pretty small change in this case, but again, if you're staring at a wall of code, where to put the small change might not be obvious to a new person. So you can use these code assistant features to help do some really cool new things, building off of examples that other people have done before. Okay, so as we wrap up, let's go over some things about working in chat-enabled notebooks that hopefully you've seen some examples of as we've gone. Now, we want to remember that context is everything to these models. So include these chat delimiters. Again, depending on your keyboard setup, they might be in slightly different places, but they look like this once you get one in there. If I put something here and then say, can you see anything I just said about modeling a PDE? And we will see what it has to say back. Waiting on a response. Yep, I apologize, but I don't seem to have access to that. That's because we put this block here so that in the other examples where we don't have these blocks, it can read what's above until it gets to the next delimiter. But wherever you see one of these, the model will not have access to for various reasons, either because you didn't want to give it that context, or you wanted to test and see how it did with or without that context, let's say. So use these personas and other prompt repository items. So again, there's a shorthand notation, which you can find linked in the guide here. There are all kinds of keyboard shortcuts and places where you can find different personas in menus. You can use this nice @ notation and start typing, let's say, what's a fun one? There's a Shakespeare one. Can I remember his name? William Playwright. Yeah, so there's a Shakespeare one here. So if I want to talk to a particular persona, we can type that in, and then we can get a persona loaded up. And then if I ask something here, it will speak to this particular persona. So if we combine all the tools available that are to us, right? So you'll see as we've gone through this particular chat-enabled notebook, sometimes we were using calls to Wolfram Alpha, sometimes we were working with Wolfram Language code. We could have that code written by the large language model. We could also take code that someone else wrote, put it right into the middle of our notebook, and then ask the model to explain this code to us. So make sure that you're combining all the different tools that are available to you and have this mentality that generative AI is good for particular things, Wolfram Alpha is good for particular things, just plain writing code is good for particular things. Again, this example that we had up to the top, if you'll excuse my scrolling, if you knew that plot range was an option, this is by far faster to just type this in than to ask a model about it, but it requires having a little bit of background knowledge. So again, as you're building background knowledge, the more that you can provide to the large language models, the more they'll be able to help. And then eventually you'll just pick it up yourself and you might not need them for something as simple as this. So use all the tools available to you, pick the right one for the job. And then if you want to control what model you're speaking to or what temperature you're using, keep in mind that you can do those as well. So as we wrap up here, there's different flavors of AI tools that we have. So there's image and text generation. You can translate things into a symbolic computational language using Wolfram Alpha. There's all the traditional machine learning techniques that came into their own well before generative AI was up and working as well as it is today. So don't forget these. They might be exactly what you're looking for a particular project. Remember, the key human input to the LLM interactions, you can basically summarize as follows. So if you can provide the initial ideas and questions, refine the details, introduce key concepts when relevant, provide the critique and corrections in case the model goes off the rails, and then provide relevant extensions. These are the things that if you go into an interaction without providing these yourself, you can still get somewhere. These tools are really great, even if you're just exploring an area that you have no background in. However, if you can provide those additional details, you'll get much more mileage out of using large language models to help you in your work. So I think this is really the key point, because it's good news for educators and for students. There's still value in the students picking up lots of background knowledge that they can use in order to go even further using these new tools. And computational thinking, you can consider an umbrella for many of these key skills. So how can you break down problems into chunks that generative AI can manage? Prompt problems are a nice example of doing this. How can you build background knowledge for better prompting? How can you interpret data to inform your decision making? How can you evaluate the effectiveness of alternate models? How can you communicate effectively for collaborative problem solving, either with your peers or with one of these large language models? All of these you could consider fitting under the umbrella of computational thinking. And so if you're looking for resources to help you learn computationally, do check out places like the Wolfram Summer School, all kinds of great Wolfram U courses, online books that are available, posts on Wolfram Community, and things like the Wolfram Emerging Leaders Program and Student Ambassador Program. So I want to thank you all for being here.